Hello, everyone. Good morning. I welcome you all once again to the mathematics class. So, in order to build a very sound problem-solving skills, so I told the student that it is important they solve question constantly. So, one of the assignments I give to them is this, and we quickly want to profile the solution to this simple question as we have it above. Though by structure it looks a little bit complex, but it being complex is not doesn't mean it is difficult, right? Though the question might look complex, but uh, solving it is a very easy task. So let's go into how this thing can be solved. So as the question is written, so we know we have to find a plus b into 4 times 5cd minus 2ab everything over c squared plus d squared. Now, and severally I've said it that in order to deal with question like this, right? So we should first of all go to the required part of the question, right? So from the requirement, one of the things we can do there is let's observe what we have in the required part of the question, whether it leads to a known identity or something similar to a known identity. So it can give us something of that nature, then it may mean that the solution can begin with what? With the required part. So one of the good things we can do here is we can try to open these brackets. And even before that, so let's consider numerator as well as denominator. So we are going to realize that they don't have anything in common. So once they don't have anything in common, using a letter to represent some common thing will not work in this case. So one of the things that can work is let's try and manipulate it the way it is, whether it can lead to a known identity or about to lead to a known identity. So if it can give us something of that type, then so it may mean that the solution may begin with what? With the required part of the question. And all we just do is when we get to a stage, we'll not be able to go ahead rather than to go back to the given and pick some value. But first and foremost, it will be important we check what we have here. So one of the best way we can check it is we multiply, right? So if I try to multiply this thing, okay, so what it will give me is not going to be any known identity and is in no way related to any known identity, right? So to solving this thing now means we have to rely on the given part of this question. And using the given part of this question, the given part will enable me at the end of the day to get the value of A, B, C, and D. And having gotten the value of A, B, C, and D, what will I do? Now, what I will do then is I will plug in those values of A, B, C, and D into the required part of the question. And with that, we'll be able to what? Arrive at the answer and or the conclusion of what? Of what we are asked to do. So to doing that, so since dealing with it from the required part is not making sense now, then it will make sense we do what? We go straight into where? Into the given part of the question. And what are the given? So the givens happens to be two different equations. The first equation is a squared plus b squared plus c squared plus d squared is equal to 4. We can name it equation 1. And we also have a plus 2 into b plus 2 is equal to cd. So we as well can label this one equation 2, right? Now this is something involving two equations. So when we have equation like this, it may mean that one of the means by which this thing can be solved is through the use of factorization, through the use of known simultaneous equation. And by simultaneous equation, we know we can use to determine any number of unknown. But if two unknown is required, two equation has to be given. If it is three unknown we are interested in, three good equation has to be given, and so on. But in this situation, the missing values we are having that do not allow me to begin the solution with the required party happens to be 4 different unknown. That is A, B, C, and D. So we can see we are looking for 4 unknown with just 2 equations, so which means simultaneous equation is not the appropriate tool by which this given can be dealt with. So once simultaneous equation has failed us, then it shows what we can use is something simpler, even compared to using simultaneous equation, which is what the identity. So let's apply our concept or our knowledge of identity to dealing with um, what we have here. We know our identity is broadly divided into two specific parts. We have the cubic identity, we have the squared identity. So which of these identity do we think this thing has some connection to and it relates to? Then one other thing we are doing is if identity is to be applied, right? What will happen to these two equations is if we are using identity, we want to combine these two equations. So after that combination, it must be something related to a known identity. So from that, we will be able to determine the value of A, B, C, and what? And D. So all I want to do now is I want to combine this and this. And when we check the list of the identities we have based on the square identity or the cubic identity, we realize that we have an identity that has this structure: a square, b square, c square, d square. Though in the list of the identities we were given, maximum we have is what? 3 variables. But this time around is 4 variables. We can still manage with this, right? Because we have something square. Now in that list of identity, do we have anything of this type? A plus 2 into b plus 2. So we can see we don't have that. Since we don't have that, so that is a call that this second equation still needs to be adjusted. And when it is adjusted, we want to relate it to this one, that which identity talks about square of some number, right? But we need to adjust this one first. So in order to adjust this one, what we are going to do is what? We're going to open this bracket. So in that situation, a times b here gives ab, then a times 2 gives 2a, 2 times b here gives 2b, and 2 times 2 here gives 4. So we say it is equal to CD. So I will continue calling it equation 2. So far, it is this equation I'm still adjusting. So if it were to be under simultaneous equation, I may want to call this one equation 3. But let me still continue calling it equation 2. All right. Now the next thing is, remember what we want to do is, we want to combine, if we are to use identity. So identity recognizes only one line of equation or expression. So we cannot have two separate equations. So when we have two separate equations, applying identity may not be that easy or straightforward. So all we just have to do is to combine this equation and this equation into a single equation, right? So to combining it, when we combine, it must resemble a known identity, right? Now, and I know a very similar identity that came to my mind that I think I can use is the one that talks about a square plus b square plus. So let me state that similar identity. This is the case of a plus b plus c squared, which is equal to a squared plus b squared plus c squared plus 2ab plus 2bc plus 2ce, right? So this is the identity that this thing relates to, right? Since it has some relationship with this identity, so it means if I want to combine the equation 1 and equation 2, it must form something of this type, right? Now let's now see the structure of what we want it to form. So look at it. So the first part of what we have in the right hand side of this identity, right? Everything is squared. So come and check the equation 1, everything is squared. So that was the reason why I linked what I have here to this very identity. Right, then the other thing that happened is some things were added to this square. What was added to this square? What was added was 2 of crossing A and B, 2 of crossing B and C, or 2 of taking two variables at a time. 2 times taking two variables at a time. So 2 times A combined with B, 2 times B combined with C, 2 times C combined with what? A. So that one falls under the cyclic expression. So we are not going to that now. Right? Now, how do we now? Now, then the next thing we want to do is we can see that the first part of my equation resemble this square part, right, of this identity. Now, the issue I have now is, in order for me to use this identity, so then it shows that my equation 2, right, must resemble this thing, must be of this relationship. So if it is not of this form, then there will be need for me to convert it first. So before I can now what? Can progress with what? With using this identity. I hope we are getting that. All right. Let's try and make our comparison. Here is AB, right? Okay. Let's go to a place where we have AB in this identity. So we can see that that AB is not just combined, it was doubled. So it shows that where I have my AB here, this AB must also be doubled. Once it is not doubled, then it is different from this identity, right? So once it is different from this identity, and this is the identity I want to work with, then I will not have choice other than to do what? To moderate or to manipulate or to adjust this thing so that it's going to be a perfect match for this identity. So it is after then I can now progress to using this identity in dealing with this stuff. So that in a nutshell, what I'm trying to say is this my second equation needs adjustments. Look at the first equation. It perfectly matched what we have in the first part of the identity. While what I have in the second equation, remember I want to combine this with this. Remember this is combined with this, right? So, and that was the reason why the identity is stated like this. So similar thing is what we want to adopt here. So it shows I want to combine this with this. And if I am to combine this with this, it must have this structure. So what is the structure we are having here? Two letters, two variables are taken at a time and doubled. So that was why we have AB times 2AB, 2BC and 2CA. So I have to reiterate this area so that we are going to understand it properly. Look at AB we have here. So let's say A and B is combined. But is it exactly what this thing is saying? No, it is different because 2 is missing there. So once 2 is missing there and I want to use this identity, then what that means is that I have to do what? I have to double this thing. I have to multiply this thing by 2. So once that happens to this, it's going to affect every other thing in this second equation, right? So remember, it is this still equation 2. We are still adjusting it. So I have to multiply throughout by 2. I can now say that what? Multiply all through by what? By 2. So doing that, 2 times AB now gives 2AB. 2 times 2A here gives 4A. 2 times 2B here gives 4B. And 2 times 4 here gives 8 is equal to 2CD. So remember, whatever affected to the left side of this equation will also happen on the right hand side of the equation. So that is this CD2 must be multiplied by 2. So this is the latest version of our equation 2. Let me still call it my equation what? Let me still call it equation 2. All right. So let me still call it my equation 2. All right. So now the next thing is, so I haven't converted this thing to this pattern, right? What we now do is what? We will combine equation 1 and 2 into a single equation. So combining now with the a squared plus b squared plus c squared plus d squared, then plus, we are going to combine the left hand side first. So everything here combined with everything here, plus 2AB plus 4A plus 4B plus 8. I can now say it is equal to, I will now combine the value of the left hand side to the value I have here. I can say it's equal to plus 4, okay, is equal to 4 plus 2CD, right? So what can now happen is, I want to equate everything into 0. And since I'm operating with 4 variables, I can adjust it into by grouping. So what I'm going to do next is, let me say a squared plus b squared plus c squared plus d squared plus 2ab plus 4a plus 4b plus 8 minus 4 minus 2cd is equal to what? 0. So I want to remove every other item I have from this side of the equation to this place. All right. So this is still the same thing as a squared plus b squared plus c squared plus d squared plus 2ab plus 4a plus 4b. So you can see 8 minus 4 here gives plus 4 minus 2cd is equal to 0. So what can now happen is, so when I have 4 variables now, so one of the best thing I can do is I can separate it into 2 parts. A, B, anything involving A variable B should be matched together, and anything involving C and D should as well be matched together. So doing that gives A squared plus B squared. Then this is plus, yes, plus 2ab, this one, let me write it properly, then plus 4a plus 4b. So let me also say plus this 4. So I've used all this, so I'm now left with d squared. So I can now say plus d squared minus 2cd is equal to 0. All right. So in order to continue with this solution, right, what we want to do is this. So this is one of the beauty of Olympiad mathematics. So what we want to do is the whole of this thing. What does it mean? Right? And the whole of this one, we also want to know what it does, what it does mean. Something is missing here. Hey, I omitted c squared. Let me adjust this one. I omitted c squared. So let me say plus c squared plus d squared, okay, minus 2cd is equal to 0. Now, I said the point I get to now is one of the beauty of what we are doing. Now, in when we observe what we have here, right? So we can see what we actually want to do here is this information from a squared down to 4 here. We want to check what does it actually mean. From our basic identity, when we have a squared plus b squared, this one alone, this thing I have here, right, already has some meaning, right? If you can, let's recall this identity. A plus b squared is equal to what? A squared plus b squared minus plus 2ab. And a minus b squared is equal to a squared plus b squared minus 2ab. Now let's go back into this place. Because from here to here, there is nothing I can do here. It seems there is nothing I can do here again, right? So what can I now do now in order to be able to continue with this solution? But I can see that a squared plus b squared plus 2ab here is also an identity of its own, right? So this thing is an identity of its own, and this is equivalence of what? Of a plus b squared. It's only when we take the square of a and b that we'll get a squared plus b squared plus 2ab. Meaning, what is the interpretation of a squared plus b squared plus 2ab? A squared plus b squared plus 2ab is more or less the same thing as saying a plus b squared, right? Now, we are now left with 4a plus 4b plus 4. So, I can also factorize here. So, how do I factorize here? So, to factorizing this thing, I simply can say plus, we can see 4 is common to them all through. So, I can say plus 4 into, what do I have here left? A. Okay, let me not do it that way. Let me only combine this and leave the constant term alone. So let me see, plus 4a. Okay, plus, we can see 4 is common to 4a and 4b. So let's factorize that. Let me say plus 4 into a plus b. A plus b. You can see I'm still left with this 4. Let me see plus 4. Now, I want to progress to this. So now, can we see what is here? This one is also what? Is also equivalent to something when we take it back to our squared identity. So a particular identity has this structure. So when we have question that is complex like this, then what we should do, under the line of our equation we are dealing with is too long. So one of the best approach we are going to use now is we want to read those things given to us and link it to a known identity. So I can see that a squared plus b squared plus 2ab relates to a particular identity. That identity it relates to is what I will just fix to this position where I have a squared plus b squared plus 2ab. So unlike this one, I don't have a specific identity for it, right? One of the things I can do is simply to do what? Compare this and this, combine this and this by factorizing. I may still leave this one the way it is. Now let's also see what we have here. C squared plus d squared minus 2cd. This one also relates to a given identity. In fact, let me say this is the value of a particular identity. What identity is equivalent to c squared plus d squared minus 2cd? So we can see it is this identity, right? So as a result, I simply can say in short form, c squared plus d squared minus 2cd is the same thing as what? As c minus d squared. Then we can say it is equal to 0. But what I have in this place, right, can still be done in this way. Let me think of this thing, the whole information here, as a quadratic expression. So where I can say let p is equal to a plus b. So if I'm taking a plus b, using p to represent a plus b, it means this whole information here, I can re-express it as what? P squared plus 4p plus 4, then plus c minus d squared is equal to what? Is equal to 0. So I don't have issue with this. I only need to simplify this, then I combine it, I interpret, and I can get my final result. So in order to continue with this so I will use simple factorization tricks, simple factorization techniques. So that's by multiplying the coefficient of 3 squared by 4. We know that gives 4. And one factor of 4 gives plus 4. So that will be plus 2 plus 2. So this thing can be rewritten as p squared plus 2p plus 2p plus 4. Then I can say plus c minus d squared is equal to 0. So the reason why I kept repeating this one is because this one is in its basic form. Alright, so if I go ahead with my factorization, we can see p is common. I can say p into p plus 2. 2 is common here, plus 2 into p plus 2. Then plus c minus d squared is equal to what? 0. So to continue with this thing, simply means we can see here, we refactorize it, meaning p plus 2 into p plus 2 plus c minus d squared is equal to 0. So this thing I have here is the same thing as p plus 2 squared plus what? C minus d squared is equal to what? 0. And when we check this thing very well, we are going to realize that p is not part of what we are dealing with. So it would be better I do what? I replace p with what the area where I introduce p. So remember I said p is equal to a plus b. So it means what I have is the same thing as a plus b plus 2 squared, then plus c minus d squared, which is equal to 0. And in order to continue with this solution, right, what we are going to do is we interpret what we have here. If we can recall very well, so square of two numbers is equal to 0. So that one is only possible when this first number is 0 and this second number is 0. That is when this combination will be equal to what? Will be equal to 0. So in that case, it means A plus B plus 2 is equal to 0. Or it means C minus D is equal to what? 0. So we have used this interpretation so many times. Now, this is the same thing as saying A plus B is equal to minus 2. Or we can say C is equal to what? C is equal to D. Now, when we apply the identity, so we cannot specifically say this is the value of C, this is the value of D, this is the value of A, this is the value of B. But with this little information we have, I think it is enough for us in order to go to the required part of the question, right? So what will now happen is we go to the required part of the question, we will target A plus B. Whenever we see A plus B, minus 2 will represent this. Wherever we see C, we substitute it with D, because this thing is saying C is equal to D. C is defined as D. Wherever we come across D, C, or wherever we need to use C, we use D to replace it. So I think when we walk through it in that way, then we can get the desired result. So I want to rub this part so as to be able to round up with what we are doing. All right, so in order to continue, I will go straight to the required part of the question. So we are asked to find A plus B plus 4. So A plus B plus 4 into 5CD minus 2AB over C squared plus D squared. So we can say this is equal to, now we have A plus B. So A plus B here is defined as minus 2. So in this position, I will say minus 2 plus 4. Then I will open another bracket. Here I have 5CD. So that one will be 5. Let me have it here. So let me say this is equal to A plus B is minus 2 plus 4 into 5CD. So that will be 5. Remember 5CD here means 5 times C times D. Now what is C? Remember C is defined as D. So wherever we see C, we'll put D there. So that means 5CD means 5 times D. So D is not defined, so we write it as D. Then minus 2. So here is AB. Now when we go to this place, A is not defined, Y as well as B. So the two are not defined. So what we can do is we can apply this value of A plus B in either of the two equations, right? So don't worry, I will write the equation. We are going to substitute A plus B there. Maybe that one can enable me to get AB, because what I need now is AB. And I did in A, value of A is obtained and value of B is obtained specifically. We will have said that what? So that value will represent A, that value will represent B. Since that is not done, there is no big deal there. So we just go into either equation 1 or equation 2, we substitute this value there. So let me go back to my equation. Which of the two equations will make sense? Let me use equation 2, so that one will not disturb me as compared to this one. So here, A plus B, so since I've rubbed that, let me quickly do that. The result it gives me, I will transport it here. Now we can see A plus 2 there becomes AB plus 2A plus 2B plus 4 is equal to 0. All right, we now want to substitute this in where possible. So we can see here, I can write this in as AB since I don't know AB plus, but look at this place, 2A plus 2B. I think I can express that one as 2 into A plus B plus 4 is equal to what? Is equal to, not 0, is equal to CD. Is equal to CD when you check the equation 2. All right. So here I can say that AB plus 2 times, look at A plus B. A plus B has the value of minus 2 multiplied by minus 2 plus 4 is equal to what? Is equal to CD. Then also we obtain C equal to D. That is, anywhere I see C, I replace it with what? D. So that simply means C can be written as D times D. So let me continue here. So here I can say AB, look at plus 2 times minus 2, that is minus 4 plus 4 is equal to D squared, right? So meaning this cancel this, so I simply can say AB is equal to D squared. So that shows whenever I see AB, I can call it D squared. So this is 2AB, so it will be 2D squared. Everything over, this is C is here, and C is defined as D. So it shows in place of C, I will always put D there. So that will be D squared plus, this one is D. D is not defined, only C is defined. So I will say D squared. So which is the same thing as, okay, let me continue here. Which is the same thing as minus 2 plus 4 here gives 2 into 5 times D times D. That is 5D squared minus 2D squared. Everything here over D squared plus D squared here gives 2D squared. So which is the same thing as 2 times, look at it, 5D squared minus 2D squared. That is 3D squared all over 2D squared. So I can continue like this. 2 times 3D squared, so that gives 6D squared over 2D squared. In order to round up now, we can cut where possible. D square here will cancel this square. 2 in 6 here gives 3. So the final answer is what? The final answer to 3. So the solution to this equation which states that let A, B, C, and D be real numbers with A squared plus B squared plus C squared plus D squared equal to 4, and A plus B plus C is equal to CD, and finding A plus B as we have it here has the value of what? Value of 3. So remember, this one is actually not part of the solution, but we only need it in order to be able to continue with what we have to do. So this is just the short solution to this question. So on this note, I'm going to call it a day to the solution corner. So more of this easy exercise just like this will be given to us. So thanks for joining the class. Cool,